Hello and welcome to the GeoDict 2023 workshop for the digital rock physics. My name is Olga Likhacheva, and today I'm going to guide you through the first part of the workshop. Together we will learn how to import and segment digital images of a conventional reservoir rock and perform some further analysis on the segmented structure.
This workshop is pre-recorded. Nevertheless, please ask anything related to the digital rock physics anytime by writing questions in the meeting chat. We will reply your questions in the breaks. Please note that you will have access to this presentation afterwards. All the shown structures and results will be available online from the DRP workshop webpage, as well as in your virtual machine of the M2M workshop cloud. The master market team of experts for the digital rock physics in this year's GeoDict user meeting consists of our DRP business manager Christian, DRP application engineer Arne, myself, and our DRP software engineer Sven. So you will get highly qualified answers from master market experts on any related topics.
The workshop is split into two parts. In the first part, I will show how to perform import and structure operations. Therefore, you will use the artificial intelligence segmentation module on a gray value image stack of a Gildehauser sandstone and learn how to use the structure analysis capabilities of GeoDict to compute and visualize the pore connectivity within the sample. Please note that between the parts there will be a break to take a coffee or to ask your questions. The standard digital core analysis comprises 3D image processing and segmentation, geometric characterization, computation of a single phase flow to obtain the absolute permeability, computation of two-phase flow to predict the capillary pressure curve and relative permeability, prediction of the resistivity index based on a set of fluid distributions, determination of mechanical properties, and computation of reactive flow for CO2 sequestrations, amongst others. In this part of the workshop, we will focus on the first two features: 3D image processing and segmentation, and geometric characterization. Please contact us if you need further assistance for your individual projects. The aim of 3D image processing and segmentation is to create from a stack of gray value images on the left a structure on the right, valid for further simulations. We start with loading gray value data, then we segment them, process, label, and visualize the 3D image of the outcropped Gildehauser sandstone. In this part of our workshop, we will work with an outcrop of this dataset with approximately 500 voxels in each direction. Please note that we have added all these slides and further working steps as PDF to the workshop archive. So feel free to use them during and after this workshop for your own training purpose.
Now, please open Geodict 2023 and follow my steps. I will do the following training slowly, but if you get lost anyway, try using the PDF or the chat in order to catch up. In addition, please find also M2M results folder with all intermediate and target results to compare with your own data or in order to recover your work. What we are going to do first in Geodict is to select the working directory. To do that, please go to the left and on the icon of the project folder, right-click, select project folder, and find Workshop TRP and DCA. Double-click. Part 1. Please find here Results M2M and select Project folder as our working directory. Click Choose. This can be also done through the main menu on the left top. File, choose Project folder, select Project folder. Now we want to import the gray value image stack of the Gildehauser sandstone. Please click Import and find Import Geovol. We are going back to the top left to the Import Geovol. In the installation folder of Geodict, you can find sandstone stack together with some other samples. Depending on your operating system, the path can differ. To get the correct path, please click on the console in the bottom. Here in the screen, write GD Geodict point get installation folder. Select the command and confirm. Now in green, you see the path to the installation folder. You can copy it or just remember. In the Import Geovol menu, please browse the dataset. Click Browse. Here on the top, you can paste the corresponding folder or find the way manually. Home, Geodict, Geodict 2023, and look for the gray value dataset. Double-click. Gildehauser rock 4.4 micrometer. Remember this value of the image resolution. To open the file, click Open and select any of the images. Click Open. As far as the dataset are predefined by our team, to import these TIFF images, you just need to enter the resolution. As you remember, 4.4 micrometer we can choose here on the top. Please also check if you have enough memory. If not, you can crop out some voxels in X, Y directions till you get required memory for image processing in green. And you can see the green numbers are changing. As far as the structure is already predefined for the training purpose, we are going to continue on the size of the data set of 512. The memory demands and the computation time should be low. Please click Image Processing to continue. It takes some time and 3D image processing window appears on the screen. The main part of the window shows 3 flat slices in 3 directions: X, Y, and Z. On the right bottom, you can find a corresponding gray value histogram. Geodict already shows the threshold to distinguish between solid and pore phases. It's this line between white and red, pore and solid. It was made by OtsoFilter, which is default in Geodict 2023. By moving a visibility slider on the top, you can make the segmentation more or less visible on the gray value image stack. I go on the top, find the visibility slider, and try to play with the position of it. The limit left shows you only the gray image values, the limit right, the proposed segmentation. By clicking and holding the right mouse button, you can zoom in and zoom out. By holding the left mouse button, move the slice in the frame. Let us change a little bit visibility to see the difference and to slice through the structure. I change a little bit the window. And as you can see in this region, for example, the segmentation is not as good as could be. We should decide on these particles or, for example, on these sparkling minerals. Let us have a look on the contrast between pores and solids. I change visibility to the gray values, zoom in, and we see, for example, for these two regions, that the pore space and solid phase are enough different. There is no much noise, and that means that we may go without additional setting in Image Processing tab, where we can improve quality of original raw data images by using different filters. Let's have a short look on this Image Processing tab. You can find here some tools for changing the size of the images and find a lot of filters to improve the quality, if not enough. In order to make it visually a little bit easier to distinguish between pore and solid, we will turn contrast or adjust the gray value range. Please go on the top, find the gray value range, and set 40 for the bottom and 20 for the maximum limit. What we are going to do now is to create an artificial and intelligent segmentation. In Geodic, a variety of AI algorithms are available. Before starting, we should define our goal and success criteria. As I already mentioned, and what can be often found in the microcity images of the rock samples, are inclusions. For your future segmentations, you may try to distinguish more than one solid material. For example, this porous or material with another structure, or this highly absorbing one. But it's not the goal of today's workshop. Today we will segment the gray value image stack with AI random forest algorithm to distinguish simple solid phase and simple pore phase. As a final criteria to match, we choose target porosity of the typical Gildehauser sandstone sample, which is about 19–20%. Please open Segmentation and Labeling menu and go to the AI Segmentation tab. They are here next to the Image Processing, Segmentation and Labeling. Click and find AI Segmentation. Expand. I change a little bit the size. And here as well. Let's go to the middle of the sample. And zoom out. Set the name for the future results. For example, Gildehauser rock 4.4 micrometer, and we are taking away this part. Select AI model from boosted tree to the random forest. Leave number of materials to distinguish 2, material ID 0 pore, material ID 1 manual solid. Select the painting mode. And the size of the brush. For example, like this. To see what we have already painted, increase the visibility. And if you are not sure about what you have already selected, please change the mode to the erasing mode and discard your selection. You can play again with the size. Select painting mode and repeat selection of the pores. Here is too big. A little bit. like this. To have a more accuracy, change to the navigation mode, zoom in, select painting mode again, and paint some war space here, for example, here, and here. We should repeat the same selection, but for the solid material ID 1. I change the size of the page, for example, here, here, a little bit smaller on that part. The selected regions are the training regions for the artificial intelligence machine learning algorithm. Based on the labeled gray values, Geodeck built the decision tree. What is the pore and what is solid? To control how many voxels of which material you have already selected, go to the right bottom tab, label data. Make sure that the bars are approximately equal. And you see we have a lack of the solid material. Make sure to select regions from different slices. Let's go, for example, to the slice 100. Let us zoom out. And select some point there. The next slice, 400. I go back to the slice in the middle and add a little bit here to get a little bit equal bars. Now we have selected the labels and we can save them if we are sure that they are good. Let us try. Click Save Labels and give a name. For example, first try, default layer, and 2 layers additionally. Save. Now we can start training. Click Train. To To see the status of the training, we can expand this window and a little bit enlarge to see all the details. After training is finished, you can estimate the performance. Click Preview. Now, after the training is done, this button is active. Geodic displays how the segmentation would look like with the current training data. You may adjust the visibility of segmentation overlay by moving the visibility slider. Very helpful is mixed mode. AI mixed. At the same time, you can see labels, which are brighter, more intensive red, and AI prediction, which is lighter. So it's label, it's prediction. Let us zoom in. As we can see, predictions looks great. Let us make segmentation by clicking Create Segmentation. It takes some time. Geodic segments the gray value images stack into the poor and solids. If trained correctly, the AI segmentation algorithm performs always better than the segmentations based on the GUR values only. As a general advice, I would say that paint not too much, but enough and representative. Decision about representativity, it's your own decision, but do not overload the decision tree with uncertainties. You have enough space for fair labeling. Of course, if you are not satisfied with the results after the segmentation, you can label once more and train again. Again, estimate with a preview and repeat segmentation. Now the segmentation is finished and we can see that the result viewer pop up automatically. It is open on the tab Report, where we can see segmentation method, image filters use, information about the structure, and porosity and solid volume percentage of the sample. As you remember, we have used as the target criteria our porosity, and desired value is about 19–20%. Now we will a bit lower. That's why we should repeat selection labels, our training and segmentation again. Now we are again at the image processing window and would like to label additional material. Let us select a little bit more pores. And a little more solid as well. Click Train. And now preview again. And create segmentation. All right. Let us check the volume fraction information again. You can see that now we have reached the target porosity, about 20%. That happened within a total run time up to 2 minutes. Let us go now to the main window of GeoDict. What you can see now, it's a segmented structure in red with invisible white pores. And corresponding volume fields or gray value image stack in our case. You may check and uncheck structure and volume fields to make them visible or invisible. Let's go on the top and uncheck near the structure. And uncheck near volume fields. And check again. Slice through the structure in the selected direction, in our case in the X direction, by the clicking and holding with the left mouse button on the slider. At the next step, we will visualize the structure in 3D. You can do this in the toolbar by changing the view from 2D to 3D. 2D, 3D. Click the left mouse button to move the structure around. We may now look into Statistics tab. Statistics. It gives you a total amount of each of assigned phases. You can display the numbers in voxels or in volume percentage. Pores are about 20% and solid is about 80%. Let's go to the Volume Fields tab and find Gray Value Threshold section. Gray Value and Threshold. Set the Gray Value Threshold to be visualized by changing the slider position. From now, we can discard volume fields by clicking with the right mouse button on the volume fields. Let's go to the volume fields, right-click, discard volume fields. And we confirm yes. Now the image processing window is closed. Check the structure again. Let us adjust colors by using color and visibility settings from the right toolbar. Set the color of ID 1 to gray. You can also adjust rendering type of the structure. Structure render, change from box to smooth. Now the 3D presentation of the rock looks much better as before. We can also visualize the pores alone. Check pores. And uncheck visible from the solid. At the next step, we will set right constituent materials for the sandstone. Go back to the toolbar on the left top and select the icon of constituent materials. In the tab Materials, we can see two IDs, 00 pore and 01 manual. Let us set them appropriately. Click on pore. Expand fluid and select water brine. Click OK. Click Manual Solid. In the search field, write Q and find quartz. OK. After selection of the proper materials, Geodig set their constants. Check them and adjust if needed. Let us make the window a bit larger and see the list of parameters. For example, for the quartz we have a solid density, and for the water brine we have a fluid density, viscosity, and some other parameters. Please click Run to apply the parameters. Geodig asks if the quartz should be visible. You may accept Yes and uncheck Pores Visible to see the structure again. As you can see, we have got the new legend for the materials information. Here on the left. ID 0 water, ID 1 quartz. What we are going to do now, to change the description of the structure in the Structure menu on the left. Please expand Structure and find Description. Click Change Description, and here you can type your own notes. For example, Gilde Hause Sandstone. Please copy this name, select, right-click, copy, and click Run. You can find the new description in the corresponding field. Let's go on the top and click File, Save Structure As, and paste copied information in the line File Name. Right-click, paste, Gilde Hause Sandstone, save. Now we want to check the connectivity of the pores in the structure. To do so, please go to the toolbar, Analyze, find Porodict, and select it. In the drop-down menu, there is a variety of calculations available. For example, you can determine chord length distribution, find pore size distribution, you can identify pores, but for this workshop we will select open and close porosity. Please select and click Edit to set the calculation parameters. If you will check all these boxes in the Periodicity tab, in Inflow planes, and in the Neighborhood mode select Faces, Edges and Vertex, that means that the open and close porosity will be determined over all sides of the structure and assumes connectivity of the voxels over the faces, edges and vertex of each voxels. Make sure that you have checked the checkbox for the write open and close pores as the TDT file. This will make open and close pores available at the structure after the calculation. To apply settings, please click OK, and to start calculation, please click Run. As you can see, Geodict opens the result viewer on the results report. The first entry in the report is an overall porosity, which is about 20%, the same value that we have already seen in the Statistics tab. The next line is opened porosity. It's also about 20%, a little bit lower as overall porosity. The difference between these two is our closed porosity, that is enough low, 0.08. Geodict also performs a subclassification of pores. It displays dead-end and throw pores. In our case, dead-end porosity is a very low. Throw porosity, it's about 20%. Now we may load the structure with an open and close pores from the Data Visualization tab. Please click Data Visualization, find Pores as a Structure GDT and Low GDT. Let us raise main window of Geodict and the information about materials. We have seen a new material, number 2, that calls pore closed pores. Let us uncheck quartz visible and now we have an overview on the closed porosity. Let us have a look at the volume fractions here in the Statistics tab. ID 02 closed porosity is 0.08% from the total amount of voxels. It's the same value that we have seen in the result viewer. What I would like to show you next, it's one more calculation possible within the Porodict. So let's find Porodict again, Analyze, Porodict, and then the drop-down menu, find Percolation Path. Select and click Edit to set parameters. What we want to do is to display 5 largest flow paths through this structure. Let us select direction. That direction is OK. we will do the calculations through the pore space. The number of passes, please enter 5. We can leave the boundary conditions as they are here through the maximum diameter, and we should click OK. And to run the calculations, please click Run. It takes some time, minute or a couple. To see the progress, we can expand the log file. The remaining time of calculation is estimated as half a minute here in the status bar. Depending on the structure, you may get the message from Geodic that the accuracy can be improved, but it's not our case. Everything runs smoothly. And now we can see the result viewer on the tab Results Report. And here we have 5 passes through the structure with maximum diameter and the particle diameter in voxels, and how long is this pass in voxels and micrometers. The total run time was up to 3 minutes. Now let us go to the Data Visualization tab and load the results. Please click Load GDT. And click No. And go to the main window of Geodict. Together with the pores, closed pores, now you can see additional material ID 0, cold pores, open percolation passes. With a left mouse click, you can a little bit move the structure to have a better impression about the passes. You may use this tool to determine the heterogeneity of the percolation with the new structure. This might be very useful for the tight rocks. We will now have a break where you can ask your questions.